Hey guys, Mr. Wilson here. Today we're looking at factoring special cases notes. At the end of this video, you should be able to identify and factor a polynomial that is a special case. Okay, I want to say this at the beginning. It is not required for you to know these special cases. Okay, but if you understand them and know what to look for, it makes some problems easier. So here, let's look at our first problem, special case number 1. We have 4x squared plus 12x plus 9. Okay. Here, without knowing any special cases, we can do this. We look for a GCF because A is not 1. 4 goes in both 4 and 12, but not into 9. So there's no GCF here. And so we just have to use our X-box method. So we look at our X-box method. Remember, we're trying to find two numbers that multiply to give us A times C. That's 4 times 9. So we're looking for two numbers that multiply to give us 36. And at the same time, add to give us 12. Okay, as I look at those two numbers, same sign. Positive, 6 and 6. So those are my two numbers that will go in my box. In my box, I have to write my first term in the first box, that's 4x squared. Last term in the last box, that's positive 9. And then the two values that I just came up with, 6x, 6x in the middle. Remember, that's us splitting this middle term up so we can factor it. Okay, so we take out the GCF of each of these, 4x and 6x. The GCF between those is 2x. 6x and 9, the GCF is 3. 6x and 9, the GCF is 3. 4x squared and 6x, the GCF is 2x. So we have 2x plus 3 times 2x plus 3. Here we go. So what do you notice about the two binomials? They're the same. Okay, look at the original polynomial. What do we notice about the first and the last terms? 4x squared and 9. They're both perfect squares. Oops. And they're both positive. Okay, true or false? If the first and last terms of a polynomial are perfect squares, then the problem is a special case. That is false. And that's why you must always check. Okay, we kind of talked about this when we were multiplying special cases with binomials. Okay, so we would look for two numbers that are both perfect squares, okay, and positive. And in the middle, we need 2AB. Okay, and remember, this sign is going to be the same sign from our product. Okay, so here, A would be 2, B would be 3, the square root of those. Okay, 2 times 3 is 6, times 2 is 12, and that's how we get that value. So let's look at it in these problems. So number 1, as we look here, we have 9x squared, it's a perfect square, positive perfect square, and 25. Positive perfect square. So if we're thinking about this, it would be, okay, can we have 3, square root of 9 is 3, 3x and 3x, 5 and 5, and then we look for our sign here. What is our sign? It's negative. And this is how we would check. We know the first and the last terms are going to work out, 9 and 25, because that's how we came up with those numbers. We said, hey, this is how those numbers work out. We check here by just making sure that when we did negative 15 or negative 5 times 3, it's negative 15x, and the insides and the outsides, negative 5 times 3, negative 15x, negative 15x, negative 15x, negative 30x. This is how we check. So we have 3x minus 5 times 3x minus 5. Okay. Looking at number 2, we have 16x squared, positive perfect square, and 1 positive perfect square. So if we were to set this up, you'd say, okay, what's the square root of 16? 4x, 4x, this would be 1, and this would be 1. Okay, our sign, positive. Let's see if it works out. 4 times 1 is 4x, 4 times 1 is 4x. That would give us 8x. Okay, and so you see that that does not match up with this problem. So this is not one of those special cases. So we actually, in order to do this, still have to do our X box. In our X box, looking for two numbers that multiply to give me A times C, 16 in this case, and add to give me 10. Those two numbers would be 2 and 8. Okay, so in my box, I have to write my first term in the first box, that's 16x squared. My last term in the last box, that's 1, and then 2x and 8x. Then go through and get my factors together. So that would be 8x, 1, 1, 2x. And so this actually gets to 8x plus 1 and 2x plus 1. Okay. Close to a special case, but not a special case. That's why checking is important. Number three right away, we're like, okay, not a special case. We have to do the Xbox method, but wait. When A is not 1, you should check for a GCF. Here, we do have a GCF between all these. 3 is a factor that fits into each and every one of them. So when we factor out 3, we're left with x squared plus 8x plus 16. Okay, now that I've factored out that GCF, x is equal to 1. And we can just do our x. But you might notice here, perfect square, positive. Perfect square, positive. Is this a special case? Because if it is, we'd have x and x, right? The square root of 1x squared. 4 and 4, square root of 16. And our sign is positive. 4x and 4x, 8x, it works out. So here is our factors of 3x squared plus 24x plus 28. Remember that we did not forget the GCF has to be in our final answer. Okay, that's one of the most common things that happens is people forget the GCF. Okay, number 4, checking again, we've got 81x squared and 4. So hey, 81 is perfect square, 4 is perfect square. Let's check it out. No GCFs here, no, okay. So we have 9x and 9x. Square root of 4 is 2 and 2. Our sign here is negative. So we have negative and negative. Does this work out? Negative 18x. That would be negative 18x. 18, 18, 36. All right. So this works out for us. We have 9x minus 2 times 9x minus 2. On the next page. Another special case, 9x squared minus 16. This special case is easier to spot because the middle term cancels out. And the last term is negative. For this to happen, the middle terms of the binomial must have the same number with opposite signs or different signs. It's only 2 of them. Okay, notice how the first and last terms are, again, perfect squares. The answer to the problem above is 3x, because square root of 9x squared, 4, square root of 16, and positive, negative. Okay, so these are a lot easier to catch. Let's go down. Okay, so our first problem, we'll notice we got 49x squared and negative 1. Okay, perfect square, negative perfect square, no middle term. So we should notice or recognize this as a special case. This is 7x and 7x, 1 and 1. Our signs, though, are different. One's positive, one's negative. Okay. Number 2, we have x squared plus 25. you should notice really quick, hey, this is the plus 25. We can't do it the same way. Okay, so it's not a special case. We would have to try our Xbox method. I'll show you this one here. Finding two numbers and multiply to give us a times c, which is 25, and add to give us b. In this case, remember ax squared plus bx plus c. Our b value is the number that's by just the x. There's no just x here in this problem, so that must mean that 0 is by it. Okay, two numbers that multiply to give us positive 25 and add to give us 0. It's really impossible, because if we said 5 times 5, it would add to give us 10. If we did negative 5 times 5, it would multiply to give us negative 25. And if we did negative 5 times negative 5, it would multiply to give us positive 25, but add to give us negative 10. So here, there's nothing that we can do to simplify this any further. This is as simplified as it gets, or as factored as it gets. Okay. Number 3, we got 12x cubed minus 3x. Here, again, the x cubed should be a hint to us that, hey, is there a GCF here? And there is. 3x fits into both of these terms. And so when we factor 3x out, we have 4x squared minus 3x divided by 3x is 1. And so we still have a GCF already, but inside here, you should notice we have a positive perfect square, 4x squared, and a negative perfect square, 1. And so we have 2x here, 2x here, 1 here, different signs. And so here is our factor, 3x times 2x minus 1 times 2x plus 1. All right. Number 4, we have 100x squared minus 81. Okay, so as we look at this, there's a perfect square, 100x squared, perfect square. 81, perfect square. There's a minus in between. Square root of 100, x squared is 10x. Square root of 81 is 9. And that minus in between tells us that one's going to be negative, one's going to be positive. No middle term, 0. Okay? Okay, again, you don't need to know these special cases. You could factor each of these out like you did in lesson 7. However, if you're able to identify these special cases and you understand the shortcuts, these problems can be done very quickly. Just driving that home really quickly. If we had a problem, let's say, for instance, 4x squared minus 25. Okay, and we were not familiar with the shortcuts. We could do this problem, okay, because we would use our Xbox method, right, and no GCF, and we say we need two numbers that multiply to give us negative 100, and add to give us our B value, right, because our A times C. Our B value in this case, remember, as we pointed out in problem number 2, is 0. Okay, so we need two numbers that multiply to give us negative 100 and add to give us 0. Those values would be 10 and negative 10. So in our box, we'd have first term, first box, 4x squared. Last term, last box, which is negative 25. And then these two numbers, 10x and negative 10x. Okay, each row and each column, we can take out our GCF, GCF between these two, they're both negative, so I'm going to take out a negative 5, make sure all my signs match up. So then we end up with 2x minus 5 and 2x plus 5. See, so even without the shortcut, if we were just doing the Xbox method to get to our answers, we could still get to our answers. But at the same time, shortcut could lead us to our answer a little bit faster, okay? So that is factoring special cases. See ya.